In previous projects, we developed Insider Threat, a serious game that allowed us to collect data on how intelligence analysts work. When valuable software gets stolen from a fictional startup company, players search through a large set of emails, calendar events, server logs, and other documents to determine who stole the software and how. We use the data to summarize the workflow of 20 analysts as a graph. The graph is like a flowchart showing the most common actions analysts took and in what order. Actions were things like searching, reading documents, and drawing conclusions based on evidence. We had two goals in this year's project. First, we wanted to assist analysts by making intelligent and helpful suggestions while they worked. Second, we wanted to show that our visualizations could be useful in other domains besides just our game. We explored two different ways to make helpful suggestions, each with their own pros and cons. The first method for making suggestions is data-driven. Using the data we collected, we trained a neural network that can watch as a new player plays the game and predict what area of the workflow graph they are currently in. Then we can use the most popular next actions in our workflow graph as suggestions to help players decide what kind of search to perform or what documents to read next. In this example, the player reads the initial police reports after the crime is discovered. Most analysts who read the police reports then searched for more information about one of the characters named Daryl and the trade show that he attended, so our model suggests that as a next possible action. The downside to a data-driven method is that we need examples of how other analysts have worked on the same problem, and that might not always be available if it's a new problem or if we don't want analysts to mimic the behavior of others. When data isn't available, we can build a logical model of the people, places, things, and events in our fictional world. Then we can simulate that world to find possible explanations for the actions an analyst learns about while reading the documents. Here, a player discovers that Daryl requested remote access to his company's server while he was traveling to the trade show. Our model can generate at least two possible explanations. Maybe Daryl wanted to work on the software while he was traveling, or maybe he wanted to download it so that he could hand it off to a competitor at the trade show. Intention recognition doesn't require data, but it does require a bespoke logical model of the domain and expensive planning computations, so it has its own pros and cons relative to the machine learning method. Besides making good suggestions, we also wanted to show that our graph visualizations could be useful outside of the domain we designed ourselves. We launched an updated version of Insider Threat with a new culprit and new evidence to see how the graphs would generalize on the same type of question but with different right answers. We also generated graphs on the Laboratory for Analytic Science's new PandaJam dataset, which tracks how analysts search through audio files from the Nixon administration to answer questions about the giant pandas that were gifted to the United States by China. Thanks for listening. This work was a joint effort between the CORGI Lab and the Narrative Intelligence Lab at the University of Kentucky. We would also like to thank the staff at the Laboratory for Analytic Sciences at North Carolina State University for their support this year and for their help in collecting data on analyst workflow.